Greetings everyone, my name is Muhammad Ifan Tijani bin Muhammad Tasnim. In this video, I will explain to you about Agribot, Artificial Intelligence of Things system to classify and predict the quality of produce in smart agriculture. Before farmers can market their produce, the produce market requires farmers to sort their produce based on their qualities. To automate the process of grading and sorting, a deep learning model can be trained with dataset to perform produce grading and defect detection. Internet of Things (IoT) has been the enabling technology of automation and data exchange in production. The four problems that Agribot is trying to address are: the results of manual inspection of produce are more inconsistent compared to an automated solution. The traditional manual inspection process lacked traceability characteristic implementation to record, track and verify the data regarding inspected produce. The backend infrastructure needed to support and operate the automation system requires ongoing maintenance. Lastly, low granularity or detailedness during grading process. The objectives of Agribot are to develop a deep learning model using YOLO V5 detection model that can detect produce and classify the grades. The second objective is to develop middleware using Python, MQTT and Ethernet IP that enables connectivity and communication between the deep learning model and the programmable logic controller (PLC). The third objective is to develop a serverless cloud infrastructure using Amazon Web Services as the backend system for inspection result and image storing and user authentication and authorization. The final objective is to develop a mobile application using the Flutter framework to enable users to remotely monitor the inspection done. To address the problems stated, two systems have been developed. The first system is autonomous produce sorting system that can autonomously inspect produce, assign a grade to them, and sort them based on the grades. The second system is remote monitoring system to enable farmer to keep track of the inspection results. This is the four modules of Agribot. The first module is the sorting machine that is responsible for mechanical sorting of produce based on the grades. The AIoT module is responsible for produce inspection and communication with the programmable logic controller (PLC) and the cloud backend system. For the backend system module, a serverless backend system was developed on Amazon Web Service platform for data and image storing and user management system. User apps will be used for remote monitoring. This is the architecture diagram of the autonomous produce sorting system. The system flow begins with the grade detection and classification process by the deep learning model embedded in the Jetson Nano. The result of the inspections will be pipelined and final grade will be assigned to the produce. After that, middleware will send instructions by Ethernet IP to the PLC to move the index conveyor belt. PLC will send EtherCAT packet to servo driver to move the index conveyor servo motor. Lastly, the inspection result and image will be sent to cloud backend system using MQTT and HTTP protocol. This is the architecture diagram of remote monitoring system. The user apps will retrieve inspection data and image from the cloud backend system and display them to users. The user apps will also be managed by the cloud backend system. The cloud backend system is developed based on AWS serverless architecture that requires no maintenance. The deep learning model is trained to grade guava and pineapple based on the Malaysian standard for fresh guava and MD2 fresh pineapple. Now I will show you the demonstration for autonomous produce sorting system. This is the sorting machine that is used to mechanically sort produce based on the grades. Camera is attached on top of the feeding conveyor belt and connected to the edge computer, the Jetson Nano. And now a guava is put on the feeding conveyor belt. When the deep learning model detects the presence of a guava on top of the feeding conveyor belt, the deep learning model will inspect the guava and assign a grade to it. Multiple detection will be done on the single guava. This guava has been assigned a final grade of grade A, so the Jetson Nano will send instruction to the PLC to move the index conveyor to the position of grade A container. The guava inspection can be repeated for guava grade B, C, and grade reject. Now I will show you the demonstration of remote monitoring system to remotely monitor the inspection done by the autonomous produce sorting system. This is the landing page of Agribot user apps. Users will have the option to log in to an existing account or to create a new account. Now I will create a new account. After creating an account, user will have to verify the account. 6 digits code will be sent to user's email. The code is used for account verification. After the account has been verified, users will be brought to the home page of Agribot. Users have the option to add existing site or to create a new site. Now I will create a new site for USM farm. Site USM have been created. The statistic is blank because there's no machine has been added to this site. Now I will add the guava machine to this site. The machine ID is the MAC address of the sorting machine edge computer. So machine has been successfully added to this USM farm site. So for today, there's a total of 7 inspection done by this guava machine. 4 of them is grade A, 1 of them is grade C, and 2 of them is grade reject. User will have the option to view the statistic for 5-week inspection, also for 12-month inspection. Now I will add a new machine, which is a pineapple machine. This is the machine ID of the pineapple. So pineapple machine has been successfully added. This is the total statistic for guava, also pineapple machine. So user will have the option to view the statistic for a specific fruit. User will also have the option to view the statistic of a specific machine. Same with site statistics. Users have the option to view statistics for 7 days, 5 weeks, also for 12 months. So user will have the option to view the inspection image that have been done by a specific machine. So user will choose the date, also the time of the inspection. User can specify how many inspection image that user want to view. The impact and benefits of Agribot is that Agribot will decrease labor costs and time consumption. Because of this, produce will reach consumer faster, fresher, and more sustainable. Agribot promotes data-driven farming that will drive the production of fruits and vegetables. The autonomous inspection provides more consistent and reliable grading. Lastly, Agribot requires no infrastructure management with low operating costs. The uniqueness of Agribot is that it is a hassle-free autonomous produce inspection and sorting system with no need of constant maintenance. This is because Agribot adopts PLC and serverless architecture. Second uniqueness is high granularity grading system by inspecting the size, shape, and color of produce. This is because Agribot uses deep learning model. Thank you.